Okay, so these are not immediately obvious that they are quadratics. Okay? If you have a look, you've got something to be squared minus 6 times something plus 5. What could you let what?
Let t minus 6 over t equals x.
Lovely. Let it equal to x. You're substituting in. Instead of this thing, which is in brackets, you're putting x. So what you get then is x squared minus 6x plus 5. And you'd be able to solve for x. And then once you get your x's, you can put your answers equal to this to find t. Okay? Down here, what would you substitute? I can't pick x now. I'm going to use u. Generally, u is used for substituting. I always want this bit to be the x squared and this bit to be the x. Or this bit to be the u squared and this bit to be the u. So what's u equal to? X squared. Lovely. So then I would have x squared to b squared gives me the 4. Okay? So that's u squared plus u minus 6 equals 0.
And where did you get the quadratic equation from? The x squared minus 6x plus 5? Is that in the question?
This?
Yeah. Like the whole line.
This, I've said is x. I've substituted it in. So that's where it comes from. X squared minus 6x plus 5. Down here, what would I let? Remember, I want this to be x squared, this to be an x, and a number. This one's hard enough to see.
Would you square the entire line?
You can never do that.
Okay.
No. You're going to let root x equal u.
Is it not the way they have u and u? Is it not a different length?
Do you mean from here to here?
Yeah.
These are two completely different sums. Like this is an example of 1, 2, 3. And I'm going to actually do one in a minute. I just want you to see the different possibilities when you can use substitution. If I'm letting u equal root x, this is going to be plus 3u. What about here? U squared, exactly, 2u squared. Root x is u. If I square that, I get x. Okay? Okay, so let's actually do an example of one of them. This one's fine, okay? It's easy enough to see because it's bracket squared bracket, okay? Let's do 2 and 3. So, this is example 3, is it?
Yeah.
Can I get rid of the board? Okay, solve. X to the power of 4 plus x squared minus 6 equals 0. X to the power of 4 can be written as x squared to b squared. Power, bracket, power, you multiply them, so that's where the 4 came from. So if I want this to be a quadratic, what do I have to let u equal? X squared. And then I'm going to get u squared plus u minus 6 equals 0.
You always use u?
Yeah, generally you'd use u, yeah. Okay, have we factors of 6? 3 and 2. That'll give me a minus. plus 3 and minus 2 equals 0. Where'd you go from there? Split your page. U plus 3 is 0. U minus 2 is 0. So U is minus 3 and U is 2. We weren't asked for U. What do you think you'll do? Exactly. Instead of U, you're now replacing back in your x squared. So x squared is minus 3 and x squared is 2. So, a number squared, what's that always give you? A plus. No, if I square something, my answer is always a plus. Alright? That's for real numbers. So, I can't actually get the square root of a minus number yet. Okay? We haven't done it. It's told me x is an element of order. They've told me it's real. This is not real. This is imaginary. Okay? Doesn't count. So you cross it off. Okay? You can't get the square root of a minus number at this stage. Okay? And over here, x squared is 2. So my answer for x could be plus or minus the square root of 2. Okay? Now I'm going to leave it like that because it doesn't have a nice answer for square root 2. We need to check our answers. Okay? So you just go back up here and you fill it in and you check and see, are they actually the solutions? Okay? So we should verify our answers. That just means we go right back up to the top.
So is to just take this, there's no minus in front of the 3 anymore?
No, that is not a solution at all. It's gone.
Oh, okay.
The 3 or minus 3, none of that. It doesn't work. Can't get square root of a minus number, so they are not your solutions. Okay? So over here, our solutions are root 2 or minus root 2. And we need to check them. Okay? So root 2 to the power of 4, root 2 squared minus 6 equals 0. And I just throw that into my calculator. Okay? What's root 2 to be squared? 2. Lovely. 0 equals 0. So that's a solution. Root 2 is a solution. And then you check with the minus root 2. And you get the same thing. 0 equals 0. So that's a solution. If it's not a solution, if you check and it doesn't come out the left equal to the right, you cross it out just like I did here. And well, they won't ask you a question like that. So first of all you substitute, then you solve your quadratic, then you bring that back in. Okay? So whatever that was, you put it equal to your answers, then you verify. Okay, you should be verifying all your answers. Will I just do another example?
Since they're the same, could you just add the 2 and then multiply the brackets, or the squares? So, divided by 2.
No.
Okay.
No.
The
No.
powers are different. So if they were the same, then you'd be able to just
It's when you're multiplying the bases, you add the powers. There's no rule for adding the bases.
Okay.
Yeah. So do you see that root 2 to the power 4 plus root 2 to the power 2?
Yeah.
You can't do anything with those bases. You just have to get the answer.
Okay.
Okay. Okay. Can I get rid of the board?
Yeah.
So this is the next one we're going to do. So we talked about this. We said this is going to be the x squared. This is going to be the x. Okay, so we're not going to use x's because they're already there. So this is going to be the u. So let u equal to root x. You're not interested in numbers. The numbers can just stay there.
And Miss, how do you put root of x rather than x?
So generally, it's here is where you're going to be able to find the substitution. You always want the thing in the middle to be a letter on its own. So like u or t, whatever it is. So if root x is u, then you can work with this. It's very hard to figure it here, but it's easier to figure it here.
Yeah.
Okay? So what we end up with is x. How would I get an x? Square this, wouldn't I? Square and square cancel and I'm left with x. And if I'm squaring this, I have to square this. So this is 2u squared plus 3u minus 5 equals 0. You alright with that? Okay. Now, 2 5s is 10. Factors of 10. 5 and 2. Okay. 5 and 2. Factors of a minus. Plus and a minus. Plus 5 minus 2, yeah? So 2u squared. I'm going to go with the minus 2u plus 5u minus 5. What's common here is 2u. U minus 1. What's common here is 5. U minus 1. And then just put the outsides in a bracket and the inside in a bracket. Split your page. And find out what u is. Okay? So nothing new there really, it's just solving quadratics. But from there, you need to go and find out what x is. Again, they didn't ask me what u was. Okay, they're asking me to solve up here with my x's. So you're going to put both your answers equal to root x. So u is root x. And u is minus 5 over 2 is root x. And 1 is root x.
Excuse me, would Sarah Butler and Ava Dunn come to reception at the bell, please?
Okay, so root x is minus 5 over 2. And root x is 1, but I'm interested in what x is. Okay, so x is over here. If root x is 1, how would I get what x is? How do I get an x on this side? Square this, don't I? And then square that? 1. Okay.
I thought you said we can't square an entire line.
You had pluses and minuses in the last thing to square. You can't just put a square on something.
Okay.
Whereas here you can because you're squaring both sides. Okay? Okay, so x is 1 and here root x is minus 5 over 2. the square root of something is minus 5 over 2. Square root of something.
Square root of 5.
Yeah, that's going to be x.
25.
Oh, what's it telling me? Oh, x. Sorry. The question. It has x is an element of or. Yeah, so that's okay.
Why is it minus?
Because when I square it, well, minus 5 by minus 5, minus minus is plus. Yeah. It's saying root x must be a non-negative number. The square root of x is minus 5 over 2. The square root of some... Oh yeah, that makes sense. Sorry. The square root of something is minus 5 over 2. What do we know the square root of? No, that is okay. Yeah, I don't know.
Cross multiply there before.
Here?
Yeah.
And bring the 2 up?
Yeah.
But you're still trying to get x on its own, so you'd end up bringing it back down again. Yeah. We need to verify these anyway.
You have x on its own there, like x equals 25.
Yeah. I'm just trying to figure out why they're not happy with this solution. But let's fill it in and see. Maybe that's why they're not happy with this solution, because it doesn't work. Okay? So I need to verify both my answers. So I'm going to fill in. If it's 1, it's 2. Plus 3 is 5 equals 5. Great. So I know this one works. You should actually do it out.
Is that not just x is equal to 5?
Here?
Yeah. Is that, if you bring up the 4, it's 4x equals
25.
5. Then you're like, really doing you're dividing.
Yeah, 25 by 4.
25 divided by 4. Is that not just 5? Oh, sorry, no, I'm thinking of 20. Right?
Yeah. That's okay. So we've verified this one, but now let's verify the 25 over 4. Okay, so that's 50 over 4, which is lovely, 12.5, and this is, square root of 25 is 5, square root of 4 is 2, so 3 5s, that's 15 over 2, yeah, equals 5, and 12.5 plus 7.5 is 20, which is not equal to 5, so that's why they're saying it's not. Don't know why they make things so awkward. Not a solution, because the left is not equal to the right, so you cancel it. That's my solution.
Miss, if you left you already squared out the x and used it in the square root in the equation, why did you do that?
I found out what x is,
Yeah.
25 over 4, and then I put x there, but I also put x there.
Just when these
It's the square root of 25 over 4.
Okay.
I still just used the x that I had here.
Would you be able to just multiply 3 by minus 5 over 2?
No. And that's where the issue is, I think. Yeah. Okay.
Will one of them always be